All right, so continuing on, we're gonna do solution calorimetry, the pre-lab, the computer lab activity for it. Okay, and essentially we're gonna be doing the same thing, but instead of using a simulator, I'm gonna give you data from previous years, a previous semester, but you can use this as a basis for doing your own data analysis when you get your data from the lab. And you'll be working with a different compound. So let's see what it looks like. So you're going to download the Excel file, the raw data for the two solution calorimetry runs, this one right here. Okay. Now the sample thermogram sheet in this file is going to be the same one that you worked on in your pre-lab tutorial. Okay, so click this that we worked on last time. So you'll notice you still have a sample thermogram, but you have data for unknown run, standard run, okay, and two unknown runs actually. So these are experiments that were determined earlier, a few years, a couple of years ago. So let's download that file, all right, and open it. Let's see. Open the file. Solution calorimetry data. Okay. Enable content. So you have unknown run, unknown standard run, thermogram. Now, you notice the thermogram is blank again, so we probably just want to copy the sample thermogram um, from what we did earlier. Well, let's just do it over again just to make sure that, well, gives you one more time to practice. So what did we do here? We copy the pre-reaction temperatures, right? Copy there. And then you'll notice it select, so in this first column right here, and it gives you a trend line through the pre-reaction data. And then let's copy the post-reaction temperature. So this is equal to this temperature right here. And let's copy that down. And you'll notice your chart has been updated to draw a trend line through your post-reaction data. And then how do we do the slope? For the pre-reaction trend line, the slope is equal to slope equal to slope. Y values would be temperature in column G. X values would be time in column E. Okay. And your pre-reactions intercept equals intercept, open parenthesis, Y values, comma, X values. Okay. We're good. And then same with the slope and intercept for the Y, the post-reaction data. So slope is equal to, M is equal to slope, open parentheses, Y values, temperature, post-reaction temperature, comma, and time. Close parentheses. And here you're going to say this is equal to slope, intercept, sorry. Intercept, open parentheses, Y values would be the post-reaction temperature, X values would be the time. Okay, and let's just verify that those are in fact the right trend lines. So you format the post-reaction trend line, show the equation on the chart. It should have a slope of negative 0.0043, which agrees with this one. Intercept of 25.5642. So that's good. And then do the equation for this other trend line. Right click, format trend line, show the equation on the chart. And let's move that equation over here. Slope is negative 0.0019 for the pre-reaction trend line, and the y-intercept is 24.1025 or 0.103. So that looks good. Okay. Oh, I need to copy the rise time, the data during the temperature rise. So this is equal to this number. Copy that down so that I can draw a smooth curve through those data points. And you can see you have your smooth curve. And what did we say? Where did we say? At what time did we say we found the mean temperature last time? 6.6. So if you move your axis at 6.6, your y-axis at x equals 6.6, you'll find that this is going to give you your mean temperature, where your smooth curve during the temperature rise intersects with the vertical axis. Okay, and that should be, just should agree with this, that should divide that vertical line between initial and final temperature into a 63 to 37 ratio, right? So what's our pre-Y value? Initial temperature equals slope times the x plus the y-intercept. 24.09, that's going to be our initial temperature right there, right around 24.1. That's our initial temperature. That's where your trend line, pre-reaction trend line intersects with this vertical axis that we've chosen. Your post-reaction intersection with the trend, with the mean temperature line would be 1 equals slope of the post-reaction trend line times the x that we've chosen for our mean temperature line plus the y-intercept b, and that should give you 26.5358. This is 26.5, 26.6, so it's right around there. Okay, so what do we do now? What should be our T mean? Equals the initial temperature plus 63%, which is, to be more precise, 1 minus exp to the negative 1, close parenthesis, times delta T, which is T final minus T initial. And it should be 25.636. Is that right around where we're getting it? 25.636. Yeah, close enough. So that is our sample thermogram. And so we need to just make a copy of that and replace the data with our data from our standard run. Okay, so I'm going to right click on it, move or copy. I'm going to create a copy. I'm going to put that copy after standard run. Okay. So now I have sample thermogram. Sorry. It might be a good time for me to close the other one so I don't get confused. Save it. Okay. All right. Question? So I have my sample thermogram 2. And what do I do with that? I'm going to rename it. I'm going to call it what? Standard thermogram. Okay. But now I need to replace that data with my data from my standard run. This is my standard run from solution calorimetry. So I'm going to copy my temperature and time here. Control C. I go to my standard thermogram. Yeah, I'm selecting everything from time 0. And then I'm gonna paste it over here, top left column of my table, and paste it there. And things look messy right now, right? Now, let's click on our chart. Well, you'll notice the chart is only plotting up to row number 29 in our data table. So what do I do if I want to include everything? I'm just gonna drag these handles here so that I include everything. Because I have more data than I had for my standard thermogram. Let's go back right there. I think we go through column I, right? Yeah, right there. So now that includes all the data. There's still something weird about this. What's wrong with this? It's doing a trend line of these data right here, right? I want the trend line of these last data points over here. So I need to adjust. So these numbers right here from 314 to 328 seconds, that's this line right here. I don't want that trend line. I want the trend line for these last data points over here, right? So actually all of these other ones, I want to put them in the smooth curve area. So this would, the ones here in this curve right here would be within the rise time, and then you have your post-reaction data over here. So what do I do now? Pre-reaction, actually I should go pre-reaction, I should go maybe up to close to 300, right? So what I can do is this. Pre-reaction, I probably need to copy, this is just, I probably need to copy this up to close to 300. 300 is so around up to 298. So that looks better. And then I'm gonna get rid from 300 to, I think maybe up to about 600. That's probably where I'm gonna do my rise, right? So I'm gonna stop here. So from 300, so I'm gonna get rid of these rise data before 300. And then starting from 300, I'm just gonna copy all the way to 600. So the middle part of my chart goes from 300 to 600, maybe. And what do you notice? I got a smooth curve through that, but the last part, I don't want these, right? I want this all the data just starting from around 600. So I'm gonna get rid of this one. Okay, so now it's gone, but I want to fit a trend line starting from 600 all the way to the end. So I'm gonna say right here at 600, this is equal to the temperature at 600. Make that, highlight that, just so I know that that's a formula, all the way to 930. And look what I have right there. Okay. Probably a good idea to start at 21.5 rather than 21.4. So I'm sorry. For the long term, yeah, for the post-reaction data. Right there. And this is really not this is not really minutes. I think this should be seconds. Yeah, this should be seconds. If you look at the data, this is time in seconds.
Should
So,
we take out that 298 data point?
and this is seconds. The 298, yeah, that doesn't look nice, huh? So yeah, take out the 298 right there. Good observation right there. Okay, and probably add the 298 over here. Right there. I can even add the 290 over here as well. There, just so it's complete. Okay. So now what do? I need to move my axis, right? Oh, I need to change my slope and intercept now. Because look at my slope right here. It's only taking a slope of that. So what should I do? I have to increase the y and x range, right? Those y values and x values up to there. Enter. And my y-intercept should be the same thing. Stretch it out up to 290. right there. And then you'll notice there's a problem with the slope and intercept here because it's not pointing to here anymore. There's nothing here anymore. What should I do? Double click on that one. It should go from here to here and here to here, right? So what should I do? It should be from 138 to 148. So let me just re-enter that formula. I can just say this is equal to slope from I 138 to I 148. So just delete this one. I'm gonna point to my Y values, which would be I 138 through I 148. Okay. Comma. And then my X values would be in column E. So E 138 colon E 148. Ah, wrong. Oh yeah, that's correct. And then this one, do intercept equal I 130, intercept I 138 colon I 148, comma, I E 138 colon E 148 colon, close parentheses. Okay, so if you look at this, zoom out right here. So let's see if we get better agreement with our slope and our intercept. So our correct slope is question.
My graph did not update like that.
Okay.
And the same NA for intercept.
Yeah. Okay. Let me help you out. Zoom recording. Okay, so we have everything matched up. Our y-intercept for the post trend line is 21.779, 21.779. And for our pre-reaction trend line is our y-intercept is 21.513, it's 25.15513. All right, so everything's okay now. Now, except that the axis that we've drawn is at 6.6. Where should it be?
315,
Somewhere between 300 and 400. You figured out it's at 315?
about that.
Okay, so you just say you want your determination of your mean temperature at x equals 315. And then you have to click on set y-axis at that location. And right there, so what is our mean temperature approximately? 21.7, 21.69, yeah. Looks like Ian already did the work for you, for all of you. Okay, now you have to do one for unknown run number 1. Okay. Or you want to do unknown run number 2? Now this one's gonna be what do you notice about this reaction? The temperature went down. Okay. So this is an endothermic reaction. So, but the formula should still be the same because when we enter our formulas algebraically, so the positives and negatives will just automatically adjust. All right, so you need to do this for your unknown run, and that's gonna be your lab report for lab performance for solution calorimetry today. So today our focus was to determine how to determine T initial, T final, and T mean from the thermograms for solution calorimetry, and bomb calorimetry. And then after we've done this, we're gonna go to the lab. I'll show you the equipment that we have and what you need to do. You need to prepare for your experiment next week. Okay?
We can do either unknown one or unknown two.
Yeah. This is just practice anyway, just practice for you. That way, when you have your own data, you know what to do with it.